Assalamualaikum warahmatullahi wabarakatuh. We are from Group 17 going to present about thermodynamics engineering application and our topic is microwave oven. Our group members are ATIKAH, HANIFAH, Muhammad ZOHDI and me, Nur Aisyah ZAKIAH. For the working principle of microwave oven, first, microwave ovens operate on the electromagnetic energy conversion concept. Electromagnetic energy is a type of radiation waves that consists of an electrical field and a magnetic field oscillating perpendicular to one another. When a polar molecule that is one with opposing charges come into contact with these electromagnetic radiations, it oscillates in order to align with them. As a result of molecular friction and collision, energy is lost from the dipole, resulting in heating. When the water molecules contained within our food items come into touch with microwave radiation, they undergo a similar process, heating the food from within. Microwaves are electromagnetic waves with frequency ranging from 300 MHz to 300 GHz, with wavelengths ranging from 0.9 meter to 0.0009 meter. The microwave utilized in the majority of ovens operates at a frequency 2.24 GHz, and the dimensions stated enable microwaves to penetrate deeply into food and cook it from the inside, while maintaining a constant temperature in the surrounding air due to the non-polar nature of air. Next, for working mechanism of microwave oven, firstly, microwaves are directed towards the food inside the cavity by the waveguide. Microwaves penetrate the food surface and reach the water molecules contained within. Second, as the operation of the electric field varies over time, the polar molecules of water seek to follow it by altering their orientation inside the material in order to align with the field lines in an energetically advantageous configuration, namely with the positive side pointing in the same direction as the field lines. Due to the fact that these molecules change direction fast millions of times per second at the very least, they gather energy which raises the material's temperature, and this is referred to as dielectric heating. Microwave energy decays according to the inverse square rule. The cavity chamber in which we insert food is intended to maximize the heating impact of microwaves. Additionally, the majority of microwave ovens include a door switch that prevents the process from starting until the door is entirely sealed. Next, I pass the next presentation to ZOHDI.
Okay, first law of thermodynamic. What is first law of thermodynamic? First law of thermodynamic is a thermodynamic adaptation of the law of conservation of energy, distinguishing between two types of energy transmission, heat and thermodynamic work, and connecting them to a function of a body state termed internal energy. Okay, next is a law of conservation of energy. Law of conservation of energy means energy cannot be created or destroyed. According to the law of conservation of energy, it can only be transferred from one type of energy to another. Okay, in microwave ovens, mechanical energy will turn to electrical energy and then turn to thermal energy. What is the mechanical energy? Mechanical energy, this energy is used to turn on the oven and press the button on the electrical socket. This also activates the socket electrical energy. Okay, then what is electrical energy? The electrical energy from the socket is transferred to the metal tube inside the oven where it is converted into heat energy. And then thermal energy. Thermal energy can be transferred by three methods: convection, conduction, and radiation. All these methods used in transfer heat of microwave oven. Okay. Another example is a change of energy transfer that starts with the microwave ovens. The heat transfer method in microwave is radiation. Heat is transferred via electromagnetic wave such as microwave in the form of radiations. Heat is transferred by conduction when two items come into direct contact. Convection is the transfer of heat by the movement of fluids in the surrounding area. Okay, next, what happened? Thermal energy is converted from electrical energy. The heat is transferred to the meal that we are preparing. After cooking, we take out the food out of the oven and expose it to the environment, and thus heat from the food is transferred to the environment. As we go about our everyday tasks, we become hungry, eat the food, and the chemical energy in the meal is transformed to kinetic energy. The energy transfer goes on and continue the chains. I will I will pass the next slide to the next presenter.
So baking is not only heat the product, but it also triggered the biological reaction in the element of the recipe. The combination of dry and wet combination will generate a batter that is flexible, allowing the cake to expand while yet sticking together. While it is critical to use the correct amount of each ingredient, it also crucial to the account for the heat and mass transfer phenomena that occur during the baking process. So the warmth and the moistness of the cake, as well as the degree to which it swells, are all affected by this underlying system. This in turn has impact on the baked goods overall quality and flavor. So the medium was considered to be the porous and deformable with phase. So the phase one is solid. So the solid is the batter. The second liquid, which is water, and the last one is gas, the combination of vapor and CO2, the carbon dioxide. Next, a system of 5-coupled partial differential equation was solved to solve this challenge. So the 5 variables considered are moisture content, porosity, temperature, total gas pressure, and the displacement. The picture shown for the physical phenomena that occur during the cake baking. So the evaporation condensation process will raise the water content in the center of the cake so that it's called crumbs, and the water content of the cake on the other hand diminish as the approach on the surface. So that's we call the rise, and this physical phenomena will contribute the creation of substantial moisture content gradient, and this gradient cause the porosity and thermal hydric and mechanical properties to be the heterogeneous, and the heating mode influence this varied property even further.